Okay, welcome back. So we're gonna talk about permutations of multisets. What does it mean by multiset? Permutation of multiset. It's basically where there are the same things, and then what are the possible arrangements to it. Remember back in permutation, we say it's n different objects, right? We choose k without repetition in order matters. But the difference between this permutation and permutation of multisets is that they're the same objects, or there are same objects. Not they're all the same, but they are same objects. So how do we do it? How do we know the possible arrangements? Well, of course we can list it down. So let's do it first. There's AAB, there is ABA, there is BAA. So there are three different arrangements, right? But then you can also think of it this way. Let's say I mark the two A's as A1, A2, and B. So then of course the arrangements will be, because now I treat them as different things, so it will be 3 factorial. But because A1 and A2, they are the same thing, so we count the possibilities twice. So what do you mean by twice? So let's say A1 B A2 and A2 B A1, they're the same thing, right? And A1 A2 B and A2 A1 B, they're the same thing. We count them twice. So what we do is we divide by 2 factorial, basically the permutation of A and B. Yeah, so also it equals to 3, which makes sense. And in the next example, AA and BB, we can of course list them down first. So it will be AABB. Well, I'm not gonna list it down so much. So we can think of it as A1, A2, B1, B2. So 4 things. We do the normal permutation. It's 4 factorial. But then A1, A2, they're the same thing. So we divide by 2 factorial, which is the permutation of A1 and A2. But then B1 and B2, they're the same thing. So then we divide by 2 factorial. Right? Okay. So from this, you can kind of come up with a formula. Let's say I have n things and things. And let's say I have, well, not n things, let's say let's say n things. So then it will be n factorial, right? We see them as different first. And let's say I have, like the example, 2 A's that are the same. Then in this case it's a random number, let's say k, are the same. Then you divide by k factorial. And there's also m the same, n factorial. There's also l the same, so l factorial. Well, and then you divide by the things that are the same. So this looks really weird. What does it mean? So let's say I have let's say, what's a good word? Okay, let's say battery. BATTERY. Okay? Then there are 7 alphabets. So we treat them as different things first. So 7 factorial. But then the T's are the same, right? So then it's divided by 2 factorial. There's also a very well-known example, Mississippi, MISSI, right? How many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 alphabets. So we treat them as 11 different things first. So 11 factorial over the same S's. So there are 4 S's, so over 4 factorial. There are 4 I's, so also divide by 4 factorial. And there are 2 P's, so we divide by 2 factorial. So these are the possible arrangements. So just to recap, if you have n different things, let's say in the case of AABB, then you first treat them as different things, so it's n factorial. And if you have then you divide by the permutation of the objects that are the same. In this case, AA and BB. So divide by 2 factorial, 2 factorial. In this case, let's say K factorial, M factorial, and so on. Yeah, like the case of battery and Mississippi. So I hope you understand, and we'll see you in the next video, which I will be covering permutations with repetition. See you then.